Yes, welcome. Today we are going to be learning about the resistance calculations. Normally in a circuit, we have more than one resistor. We don't have only one. We normally have in circuits that do functions, we have more than one resistor. So if you have resistors that are connected either in series or in parallel, it is always a question from bodies like JAMB and WAEC that require that you get the effective resistance. Effective resistance simply means the total resistance in a circuit like this. Look at this circuit. This circuit has how many resistors? 1, 2, 3, 4, 5, 6, 7. So what is the effective resistance of this circuit? So when you are asked the effective resistance, it implies the calculation or the manipulation of all these resistors, all the resistance of these resistors to give us one the resultant resistance. So we are going to learn how to do this calculation. And like we learned in the previous lesson, resistors can be connected in series or in parallel. So connection can either be in series or in parallel. So when you have such resistance connected in either in series or parallel, you're supposed to do the calculation to find out the effective resistance. So number one example that we are having here is determine the effective resistance of the resistors in the circuit below. This is the circuit. You can see that the resistance of this resistor is 3 ohms connected to this one, 3 ohms, to another one, 2 ohms, to another one, 2 ohms, to another one, 2 ohms, 3 ohms, and 4 ohms. So how do we do this calculation? If you look at this circuit now, you see that if this circuit is redrawn, you can see that this 3 ohm resistor is in series with this 2 ohm resistor, and this is what we try to have here. First of all, we have to, in the solution, we say first we redraw the circuit. We have to redraw the circuit so that we have the right picture. If you look at this 3 ohm resistor and this 2 ohm resistor, you see that they are in series, and that's why here now I connected them in series. This 3 ohm resistor is this one, but this one and this one, I now put them in the normal way that they should be. So you now have 3 ohm resistor here and 2 ohm resistor. Now connected, here we have 2 ohm resistor. Then if you look at this 4 ohm resistor and 3 ohm and this one, you see that all of them are also in series. So you have 4 ohm resistor, 3 ohm resistor, and 2 ohms resistor. So you see that this circuit is the same thing as this circuit, only that it is drawn in such a way that the effective resistance calculation can be done easily. So if you're able to redraw this circuit to be this, then the calculation becomes very simple. This is in series with this, so you can simply add up 3 ohm plus 2 ohm is what? 5 ohms. These three resistors are also in series, so you have 4 ohm plus 3 ohm plus 2 ohms. You have what? 9 ohms. So you now we've now reduced this resistor, this circuit to this. This plus this 5 ohm, this plus this 9 ohms. So we still have the 3 and you still have the 2 ohm resistor. So now you have 2 resistors in parallel, whereas these other ones are in series. So what do? You find the effective resistance of these 2 different resistors. And to find the effective resistance of 2 resistors that are in parallel, you say 1 over R effective equal to 1 over the resistance of one of them, which is 5, plus 1 over the resistance of the other one, which is 9. So finding the LCM of 9 and 5 is 45. So 45 divided by 5, you have 9 times 1, 9. 45 divided by 5, you have by 9, you have 5 times 1, 5. So if you add 9 plus 5, you have 14 all over 45. So if you take the reciprocal, you now have 45 all over 14. So that is the effective resistance of these 2. So if you have the effective resistance of these 2 to be 45 over 14, Then you can add it in series with this other remaining 2. So you now have 3 ohm resistor plus this, which is 45/14, plus this, which is 2. So you can now simply do the mathematics. You have 3 plus 2, 5, then 5 plus 45/14. So I will allow you to press the calculator so that we can get what 45/14 is. Once you get it, add it up. That is the effective resistance of this whole circuit. So you look at the procedure that I've taken. First of all, you have to redraw the circuit, this circuit, to give you this. Pick out the ones that are in series easily. 3 plus 2, 5. 4 plus 3 plus 2, 9. Add this one up using the formula for calculating the resistance in parallel, which is 1 over effective resistance equal to 1 over the individual resistors, which are 5 and 9, to give us 14/45. Then take the reciprocal to get the effective resistance to be 45/14. So you now add up this 45/14 for this plus 3 ohms plus 2 ohms to give us the final effective resistance. So I would like somebody to give me the answer while we close for the day and start again later.